Chapter 2, Properties of Fluids. All right, class, today we're going to play pretend. Imagine you're holding a cup of your favorite drink, maybe water or juice. What you're actually holding is something called a fluid. Now, fluids are all around us. They can be liquids like water or gases like air. When we talk about properties of fluids, we're asking a simple question. What makes this fluid special? Now, first, let's talk about something easy, how we measure stuff. Some things stay the same no matter how much you have, like temperature. Imagine breaking your cup of water into 2 cups. Both have the same temperature. That's called an intensive property. But some things change when you have more or less of it, like the total amount of juice. That's called an extensive property. Easy, right? Next, we think of fluids as being smooth and whole, like a big cake, not broken into tiny crumbs. Even though fluids are made up of billions of molecules, we pretend we don't see them and imagine fluids are smooth everywhere. This makes it easy to study, kind of like drawing a circle instead of counting every tiny dot inside it. Now, let's talk about weight. You know when you lift a box, you feel how heavy it is. Well, for fluids, we think about how much weight is in every little space, like how many kilograms of juice are in 1 liter. That's called density. And if we compare how heavy one fluid is compared to water, we call it specific gravity. Like if oil floats on water, it means oil's specific gravity is less than 1. You've also seen steam come out of a boiling kettle, right? That steam forms because when the pressure is just right, water turns into vapor. That pressure is called vapor pressure. If the pressure in a pipe drops too low, bubbles pop out of nowhere and make weird noises. That's cavitation. It's like the pipe is coughing because of those bubbles. Now, when you run, you use energy. Fluids also have energy. When they move fast, that's kinetic energy. When they're high up, that's potential energy. When they're hot inside, that's internal energy. And when they flow, they also have something called enthalpy, which is like their extra energy ticket for moving through pipes. Let's pretend you squeeze a balloon. It squishes because you changed its pressure. How much something squeezes or expands with pressure is called compressibility. And how much something gets bigger when you heat it is called the coefficient of expansion. Like how hot air balloons rise because the air inside gets bigger and lighter. Sound is fun too. When you shout across a field, your voice travels through air. The speed your voice travels is called the speed of sound. And if you move faster than sound, like fighter jets do, you get something called a Mach number. Normal planes go slower than sound, supersonic jets go faster. Now, let's talk about something sticky, viscosity. Imagine trying to stir honey and water. Honey feels heavier and slower. That's because honey has high viscosity. Water moves easily, so it has low viscosity. Some fluids, like water, behave nicely. They follow the rules, and we call them Newtonian fluids. But things like ketchup are naughty. They don't follow the same rules, and we call them non-Newtonian. And lastly, think about bubbles. Why do water drops look round on leaves? That's because of surface tension. Fluids don't like to be disturbed. They like to be tight and cozy, pulling themselves into little balls. So fluids might seem like simple water or air, but they have many fun secrets inside. Density, energy, stickiness, sound speed, and even bubble-making powers. All these little things make fluids behave the way they do in cars, airplanes, kitchens, and even nature. And that's why engineers, like us, love learning about fluids.